If you want to have a copy of this module, I've linked it in the description of this video. Lesson 3. Problem solving involving sets. In this one, we will also use Venn diagrams to help us solve sets. So, one of the best ways to do this is through example. A class of 28 students were surveyed and asked if they ever had dogs or cats for pets at home. 8 students said that they only had ever had a dog. 6 students said they had only ever had a cat. 10 students said they had a dog and a cat. 4 students said they had never had a dog or a cat. At each problem involving sets, you should always know your universal set, in which case we had a class of 28 students that were surveyed. So our universal set is 28 students. To represent this in a Venn diagram, it is going to be a rectangle. Then identify how many sets you have. In this case, it is those who had dogs and those who had cats. Let D be those who had dogs. Let C be those who had cats. And for each one in the Venn diagram, it is going to be a circle for 1 and another circle for 2. Labeling this as our universal set, C for cats, D for dogs. Let's read the note here that the word only is extremely important in Venn diagram word problems. Because the word only is in our problem text, it makes it an easy word problem. Looking at the statement here, 8 students said they had only ever had a dog, meaning that they never owned a cat, exclusively dogs. Because the overlapping circles here are those students who had both a dog and a cat. Continuing on, 6 students said they had only ever had a cat, meaning 6 students exclusively owned cats. Then we have 10 students said they had a dog and a cat, meaning they had both owned both cats and dogs. 4 of which said they never had a dog or a cat. We will put them outside these 2 circles. And there's an example of a 2-circle Venn diagram. Let's have a deeper understanding by doing some more activities. A. In a group of students, 65 play basketball, 45 play volleyball, 42 play chess, 20 play basketball and volleyball, 25 play basketball and chess, 15 play volleyball and chess, and 8 play all 3 games. Find the total number of students in the group. We're going to assume that each student in the group plays at least 1 game. Let me just draw the Venn diagram for this. A rectangle for our universal set, a set for those who are playing basketball, a set for those who are playing volleyball, and another one for those who play chess. And there's our Venn diagram. Our rectangle is all the students who are participating in a kind of sport. We have a set for those who are playing basketball, volleyball, and chess. In the given, it says 65 play basketball. This does not necessarily mean that 65 exclusively play basketball. No. It means that regardless if they're playing other sports, 65 play basketball. Same thing with volleyball and chess. When answering a Venn diagram, always go to the overlapping circles first. starting at the center. We know that 8 play all 3 games. There are 8 people here who play basketball, volleyball, and chess. Looking at this given, 20 play basketball and volleyball. Here are their circles, and we don't want to put 20 here. No, 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 because 8 of those 20 are already playing chess. So 20 take away 8, that gives us 12. This is still correct. 20 play basketball and volleyball. 8 of those 20 play chess also. Going with the same logic with basketball and chess, 25 take away 8, that gives us 17. And finally, the last overlapping circles, 15 play volleyball and chess, 8 of whom are already playing basketball. 15 take away 8, that gives us 7. We have now enough to answer the onlys. Those who play basketball only is simply take the total number of those who play basketball and take away those who are playing other sports. Those who play volleyball and basketball, those who play basketball, chess, and volleyball, and those who play basketball and volleyball. And this gives us 28. Those are the ones who are only playing basketball. Same logic for the volleyball. Take the total number of those who play volleyball and take away those who play other sports also, which gives us 18. Finally, chess. Those who play chess are 42. Take away those who play other sports. That leaves us with 10 who only play chess, 18 only play volleyball. We also assume that each student plays at least one game, so there is no student who does not play any of it. We can now find the total number of students in the group by adding all of this. The total is 100 students. Notice that if we add 65, 45, and 42, which are these ones, it will not add up to 100 because most of them overlapped. Next, we have B. In a class of 60 students, 40 students like math, 36 like science, 24 like both subjects. Find the number of students who like A. Math only, B. Science only, C. Either math or science, or D. Neither math nor science. This is a two-circle diagram. This is a two-circle Venn diagram since we only have math and science as our sets. Here's our universal set. One for mathematics, another for science. Let's label this as universal, math, science. Let's put in the given. Always start at the center. We have 24 who like both subjects. In math, there are 40 students. 24 of them also like science. So 40, take away 24, and that gives us 16 who like math only. In science, you have 36. 24 of them like math also. 36, take away 24. That gives us 12 who like science only. Now, this is a class of 60. Let's see if there's going to be students who don't like math and science. Get that 60 students and take away those who like math or science. And that leaves us with 8. 8 students don't like math or science. I believe we've answered every single one here. Math only, there are 16 students. Science only, there are 12. Either math or science is not 24, but also adding those who like science or math. So 16, 24, and 12, which gives us 52. Neither math nor science is going to be 8. One final question. In a survey of university students, 64 had taken mathematics course, 94 had taken chemistry course, 58 had taken physics course, 28 had taken mathematics and physics, 26 had taken mathematics and chemistry, 22 had taken chemistry and physics, and 14 had taken all 3 courses. Find how many had taken one course only. Let's construct our Venn diagram. Our universal set, one for mathematics, another for chemistry, one final one for physics. Label this as U, mathematics, chemistry, and physics. Again, with Venn diagrams, start at the center. 14 had taken all 3 courses. Looking at math and physics, there are 28 of those who take math and physics, 14 of whom took chemistry also. 28, take away 14, we have 14. Looking at math and chemistry, 26 had taken mathematics and chemistry. 14 of those 26 had taken physics also. 26 take away 14, we have 12. The final overlapping circle, physics and chemistry, there are 22 of them, 14 of whom have taken mathematics also. 22 take away 14, we have 8. Now we go to the onlys. In the mathematics course, there's 64 of them. 64, take away those who are taking other subjects also, and we have 24. In the chemistry course, we have 94. 94, take away those who are taking other courses also, and we have 60. Lastly, we have those who are taking physics course, 58. Take away those who are doing other courses, and we have 22. Now we can answer those who had taken one course only. We have those 24 in mathematics, 60 in chemistry, and 22 in physics. Add all of them up, and we will have 106 students who are taking one course only. Remember, in Venn diagrams, always go from the center going out. That's it. End.